course of graphing and data analysis, you will hear me say over and over again that graphs must be full page. We want to make them as large as possible and spread our data out as far as we can. And then you'll further hear me say when you go to calculate your equation for your line of best fit, that you're going to want to choose points which are as far away from each other as possible on the page. Begin searching at one end of the graph and go up to the other end of the graph. So I say these things as general rules, but I wanted to take a moment and explain to you why that is the fact. Okay? So, and also why it is that we are not permitted to use data points when calculating our line of best fit. Okay? So we'll take that first bit first, okay, or the last bit first. Why can't we use data points? The simple answer is because odds are you didn't put the data point where it actually is. You did some estimation. You think that it was supposed to be there, you did the best you could to put it in the right place, but we don't actually know that where you put that point is actually where the data point should have been. So we can't then use the value of the data point and pretend that that's a point on the line. We simply don't know that that is true. So that's it. We don't use data points because we cannot definitively say that the data point is actually on the line, even if it looks like it. There's too much estimation involved there. So we're going to search our line and choose points which we can find the actual value. Okay? And we'll discuss that in class and go into more detail, but the idea is pick 2 points that you can find the values and use those instead. So why is it that we want these values to be spread out really far? If I have 2 points which are close together, and I've made small errors about the exact location of them, and then I go ahead and determine a line through them, or really 2 lines through them. I'm exaggerating this a little bit to show the extent to which the error can happen. But if I have 2 points close together, the rule is I have to determine a line which goes through these 2 points. Well, if there's a little bit of uncertainty about how high these 2 points are, then the difference in the acceptable lines I can draw that will still meet the requirement of passing through both points, these are very different lines. We can see that the farther out we go, the more that difference is exaggerated. So, again, this comes down to we choose these points as carefully as we can, but if they're very close together, any small mistake we make about how close it is to the line and what its value is gets exaggerated very greatly. However, if we take 2 points which are far apart from each other and do the same activity and attempt to draw 2 lines exaggerating as much as we can, sort of saying how badly could we do this while still meeting the requirement of going through both points. Here we see that if we choose 2 points that are far apart, even if we made an error, the amount of a difference that makes is very small. So by choosing points at opposite ends of our line of best fit, we do a lot to minimize our error and make sure that our answer or equation is as good as it can possibly be.